Hi guys, so I am covering Learning Goal 4, which has to do with terrestrial planets, their interiors, and their heating and cooling processes. So first we'll take a look at Earth. In the interior of Earth, we have the solid inner core. Next, we have the liquid outer core. Next, we have the mantle. And lastly, we have the crust. And in addition, the mantle can be broken into two parts, the continents and the ocean floor. And the mantle and crust can be included in what's called the lithosphere. So we actually obtained all of this information from earthquakes and their waves, which are obviously very scary, but they're also very informative. Now, with the understanding of Earth's interior, we can analyze and better understand the interior of other planets such as Venus, Mars, Mercury, and even the Moon. Although it is much harder for us to obtain data on these planets, we have used the law of universality and the masses and radiuses to get what we know as density of the other planets. And this allows us to conclude information on their interiors. As we can see from these photos, each terrestrial planet with the moon included have different interiors, but they can all be compared to Earth. All of these differences in the interiors of the planets affect the heating and cooling of the planets. When the terrestrial planets formed, they still had a great amount of heat left over from collisions and short-lived radioactive isotopes. This is how the planets melted and underwent differentiation. Many radioactive elements are trapped in the interior of the planet, and these elements decay, which then release energy and heat the interior. However, we also see a cooling from the surface of the planets, forming the crust and solidifying the mantle and inner core. This process is very slow and happens over eons. The planets are still being heated from long-lived radioactive isotopes. Also, we know that the center of Earth is solid because the intense pressure overpowers the high temperature. Planets lose their thermal energy through the process of convection, conduction, and radiation. Each of these processes are importantly related to the surface area to volume ratio of the planet. This is the ratio between how fast a planet is able to cool and its surface area. A larger surface area equals more rapid cooling, and a smaller surface area equals slower cooling processes. This is why, for example, Mars has cooled much faster than Earth because it is much smaller, so its surface area to volume ratio is larger. I hope this was helpful, and thanks for watching.